We can use the quadratic formula, which I've written down at the top here if you don't have it in your notes, to solve any kind of quadratic equation, anything with x squared in it. In the past, we've used factoring to solve, which is great. It's pretty easy to do, and the problem is it doesn't work all the time. We've also used square roots to solve, but again, that only works for a specific kind of equation where there was no x term. You may have also used completing the square, which works all the time, but some people don't like it. So here's quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. So let's go ahead and take a look at how that formula works to solve a couple of these quadratic equations. So first thing first is kind of like factoring. You cannot do anything until you're equal to 0. So if you're not equal to 0, make sure you rearrange your equation first so that you are. Once we've done that, let's go ahead and identify what a, b, and c are. There are coefficients in order of x squared x and then the constant. So in this case, a is 1, b is equal to 3, and then c is equal to negative 2. Now, what you might want to do before you do quadratic formula, you may want to try to factor, because if you can factor, it'll probably be quicker to do. In this case, if I tried to find two numbers that multiplied to negative 2, but added up to positive 3, I'm going to see real quick that it's not going to be factorable, meaning my solutions are not integers, they're not rational. Either they're irrational or they're imaginary. So I wouldn't be able to find them with factoring. So we are stuck using the quadratic formula. So let's take a look at how that works and simplify it. So x equals the opposite of b. Well, if b is 3, the opposite of b is negative 3. Plus or minus the square root of b squared. Always include the b value at this point in parentheses, especially if that b value is negative. If you don't have parentheses, you're going to get this wrong. So include parentheses. Minus 4 times a, which is 1, times c, which is negative 2. And then that whole thing, not the x bar, but the whole thing is divided by 2 times a, which is 2 times 1. Okay. At this point, what I do not want you to do is reach for your calculator and try to type this in all at once. If you do that, chances are really good you're going to make a mistake because there's so much going on with this. So do not type all this in at once. Instead, here's what I'd recommend you do. If you're going to use a calculator, start with what's underneath the square root. So do this part first. You can type all that in your calculator. Just don't type in the square root part because we don't want to get decimals yet for these unless it's said to. So let's just leave the square root around it, and then in the calculator we can type in what's underneath there. It's called the discriminant, if you've heard of that before. We're not going to focus too much on it right now. But 3 squared minus 4 times 1 times negative 2 gets me an answer of 17 once I simplify that. My denominator is just 2 times 1 or just 2. Now before you finish it, some things to check for. Check and see if you can break or simplify the square root by breaking it down. 17 is prime, so there's nothing we can do with that. Also, check to look at all three numbers outside. Like some of you don't see that third number. Remember, there's a 1 right there if we want to. So looking at negative 3, 1, and 2, see if there's a number that all three of those are divisible by, and if there are, divide that out. In this case, there's not, so there is my simplified answer. Notice it is irrational. Square root of 17 is irrational. That's why the problem wouldn't have factored. But that still represents my solutions. If I were to graph this parabola, like we've talked about before, I would see two x-intercepts, and if I found those two x-intercepts, they'd be whatever the decimal version of this number is. Now would be a good time to pause the video and try a couple of these on your own. However, if you need to see a few more examples, I'll work through 2 more of these. Otherwise, it's all pretty much the same thing. So this would be, like I said, a good time to pause and try on your own. All right, so first up, if you're watching these to see what I'm going to do, I'm going to, again, make the problem equal to 0. So I'm going to subtract 5 from both sides and become equal to 0. Now, at this point, we wouldn't want to try factoring it because we have a negative number in front. So actually, what I'm going to do is I'm going to divide everything by negative 1 or just change all my signs. So x squared minus 4x plus 5 is then, well, 0 is just 0. I can't change the 0 sign. And that's something that I might want to try to factor. If I tried to find two numbers that multiply to 5 but add up to negative 4, I'm going to once again find that that is impossible, so this one is not factorable, meaning I cannot, I won't get rational answers. They'll either be imaginary or they'll be irrational. So let's list out what a, b, and c are. So a is 1, b is negative 4, and c is positive 5. Now if you did this problem on your own, maybe you didn't switch the signs like I did, and you use your a, b, and c values at this point. So your a, b, and c would all be opposite. You'd have negative 1, positive 4, and negative 5. Go ahead and watch how I'm going to do this problem, and you'll see that it doesn't matter. I'm still going to get the same answer. So again, I'm going to use quadratic formula. So start out with the opposite of b, which for my case will be positive 4. Plus or minus the square root of b squared. Make sure you use parentheses around that value, especially like in this case when it's a negative value. So b squared minus 4 times a, which is 1, times c, which is 5, and then that whole thing is divided by 2 times a, so 2 times 1. Again, you may have all opposite signs in there for your a, b, and c values, but it won't matter. It's going to work out the same. Do not try to type all that in parentheses, or all that in your calculator, but instead you can type this in, the part underneath the square root, the discriminant part. And if I do that, I'm going to have 4 plus or minus the square root of, that simplifies to just a negative 4 when I do that, divided by 2. Now at this point I can see that I'm going to have imaginary answers, and I know that because I see a negative number underneath the square root, which is why it was not factorable. My solutions are imaginary. So I've got negative 4, 4 plus or minus the square root of, well, the square root of negative 4 is just 2i, so I'm going to replace that with just a regular 2i. It's a perfect square, divided by 2. Now once again I want to take a look at all three numbers, the 4, the 2, and the 1. All of those numbers are divisible by 2, so I'm going to go ahead and do that. So that becomes a 2, that becomes a 1, that becomes a 1. If I simplify that and write it a little bit neater, I get 2 plus or minus 1i, or just 2 plus or minus I. So there's my two solutions. You should have got the same thing even using opposite values. You'd have a little bit different way to simplify, but we should end up there. Now speaking about the graph, if I were to graph this to check my solutions, I'd see the parabola did not have any x-intercepts, and that's because my solutions are imaginary. It doesn't cross the x-axis anywhere. I still get two solutions, they just happen to be imaginary. Okay, and I'll do one more for you. Again, I would recommend trying it on your own, but if you want to see me work through that, same idea as last time. So let's get this entire equation equal to 0. So 25x squared, I'm going to subtract 12x from both sides to get that moved over. Negative 18x minus 12x is minus 30x. And then I'm also going to add that 9, so I get plus 9 equals 0. Okay? Try to factor it if you like. This one turns out actually will be factorable, although not with very nice numbers looking at that, but I could factor it. This time there's nothing, like last time I divided by negative 1 to change my signs around. This time there's nothing I can divide by. There's no greatest common factor, so we do have to do quadratic formula with those numbers given. So they're large numbers, but using a calculator it's not a big deal. So a is 25, b is negative 30, and then c is equal to 9. So using quadratic formula, although like I said, you could try factoring, and this time it would actually work, I'm going to get x equals the opposite of b, which is positive 30, plus or minus the square root of b squared, remember those parentheses, especially when b is negative, minus 4 times a times c, and the whole thing is divided by 2 times a, so 2 times 25. Using a calculator to simplify what's underneath the square root, this time something interesting happens. When I type all that underneath the square root into my calculator, I end up with 0 this time, and a denominator of 50. Well, the square root of 0 is just 0. I can do the square root of 0, that's totally fine. So I get 30 plus or minus 0 divided by 50. Well, the plus or minus 0 is kind of interesting because it doesn't really matter. 30 plus 0 is 30, 30 minus 0 is just 30, so it turns out the plus or minus 0 has no effect on the problem. It's just going to be a 30 divided by 50, which of course I'll simplify to just 3/5. So here's a case, because we had that 0 underneath the square root, where we get only one solution, but recall that that's really a double solution. I still always have two answers, I just get that 3/5 solution twice. And if you think about these when we talked about the double solutions before, this graph only has one x-intercept, and so what that means is it must come down, the vertex must just touch the x-axis, and it skims the surface of the x-axis and bounces back up. So we just get that one x-intercept where the vertex is.